solve for this range, this equation here, we have a double angle formula. So the first thing to do is basically get rid of that and use the fact that sine 2 theta is 2 sine theta cos theta. I strongly advise that you just learn that because there's times when you might be asked to do something with this on the right and you have to realize that it is a double angle formula. If you always just rely on obtaining it from addition formulae, then you might miss that. So please try and learn it. For now, if you haven't learned it, then look, we take our addition formula from the formula book. We just make b equal to a, replace it. So we get sine a cos a plus cos a sine a. And that you can see that will equal 2 sine a cos a. And then I just replace a by x, or theta in this case. Sine 2 theta is 2 sine theta cos theta. There we go. So our first line is then going to be 5 times 2 sine theta cos theta, or 10 sine theta cos theta is equal to 9 tan theta. Don't really want that tan theta there, so I'm going to go straight for it and write it as sine theta over cos theta. There we go. And I'm going to multiply through by cos theta. Like technically, okay, no, let me do that. 10 sine theta cos theta squared is equal to 9 sine theta. So what I was going to say is technically theta cannot equal 90 degrees or minus 90. They end up not being solutions anyway, but like when you go from here to here, you just have to rule that out as a possible solution. Okay, there's two approaches for doing this next bit. Approach number one, this is how I would do it, but you just have to be careful, is you could cancel out the sine thetas and write 10 cos squared theta equals 9. You just have to account for sine theta equaling 0, because you can't divide by sine theta if it's 0. And sine theta equals 0 is a solution to this because it would work. So that is one approach. Your other approach, if you want to be more careful, and I'm going to write it up here, is to do 10 sine theta cos squared theta minus 9 sine theta, get it all equal to 0, and then factorize out the common term sine theta. Now you see it's either this is 0 or this is 0. We get exactly the same solution, which actually gives, sometimes people say, well, why do we have to think about this one? Well, that's why, because when we do it a slightly different way, it comes in, and I've also sort of justified it the first way anyway. Like it is clearly a solution to the equation. So make sure you don't miss this one because it actually gives three different answers. Okay, it's kind of the easiest one to deal with. Don't even need a calculator for it because sine is going to look like this, but remember it's between minus 180 and 180. So it's going to hit 0 in three different places. You can do inverse sine on your calculator and then do 180 minus and so on. But if we draw the graph, we can just see theta is minus 180, 0, or 180. That then leaves us with the cos one. So cos squared theta is 9 over 10 square root, but do not forget plus or minus. Very important because again, if you don't, you've missed some solutions. It's going to be 3 over root 10. I'll deal with them one at a time. So cos theta is 3 over root 10. Let's draw the cos graph now. Okay, and first up, I'm looking at these positive values here. 3 over root 10. So it's going to be two solutions. One's positive, one's negative. So 18.434 or minus 18.434. We'll put them all together in a minute and round to three significant figures. And then my other one is going to be the negative down here. Okay, so again, two solutions. I'll just put it in my calculator and then take plus or minus that after. So 161.56. Or minus 161.56. Okay, so finally, theta is going to be, I'm going to write them in ascending order, minus 180, minus 100, wait, did it ask for one decimal place? Okay, minus 161.6, minus 18.4, 0, 18.4, 161.6, or 180. Okay, lots of solutions there. In part B, we're just then asked to deduce the smallest positive solution to this equation. Now it looks very, very similar. So I'm going to let theta equal x minus 25. And then star actually becomes double star. Because I just replace theta here, it becomes x minus 25 here, I'd get 2x minus 50. So I've actually already found the solutions for theta. So I just need to add 25 to them. Deduce this, we don't have to find them all. Deduce the smallest positive solution. I'm adding 25 to them. It's going to be when I add it to this one. I feel like technically I should use the exact answer. So I'm going to take minus, and this is why I always write them down, just in case we need to use them, minus 18.434 plus 25. That's going to give me my answer, 6.566. Sorry, I forgot what it was. 6.566. I'll just again round it to one decimal place, but look, it can be seen that I've done it to more accuracy. Okay, so we don't have to write a lot. It's just identifying it and then getting the main answer, really. I don't think I need to justify it any more than that. Okay, good question.